underlying price movements are not the only factor that will affect an option's delta. Implied volatility will also affect the delta of options. Let's take a look at the $100 call option from the example in the previous lecture and see how the delta of this option would be affected by different levels of implied volatility. Here we can see the same $100 strike call option with 30 days left until expiry. This time though, we can see IV levels of 20% in blue, 40% in red, and 60% in green. Let's look at what price the asset has to reach before the delta is greater than 0.99 for each of these IV levels. The delta of the $100 call is greater than 0.99 at the following price levels. With 20% IV, it's $115. With 40% IV, it's $130, and with 60% IV, it's $148. What this is showing is that the higher the implied volatility, the further in the money the option has to be for the delta to get close to 1. Which stands to reason, as a delta of 1 implies that it's almost certain that the option will expire in the money. And the higher the implied volatility, the more price movement the option prices are implying is possible. So the further in the money an option has to be for it to be almost certain to remain in the money at expiry. The same phenomenon occurs on the other side of the curve, of course. The delta of the $100 call is less than 0.01 at the following price levels. With 20% IV, it's $87. With 40% IV, it's $76. And with 60% IV, it's $66. The higher the implied volatility, the further out of the money the option has to be for the delta to get close to 0. A delta of close to 0 implies that it's almost certain that the option will expire out of the money. And the higher the implied volatility, the more price movement the option prices are implying as possible. So the further out of the money an option has to be for there to be almost no chance of it becoming in the money at expiry. We can also view this relationship between implied volatility and delta by taking a similar look at the delta of multiple option strikes at different IV levels, like so. This time the asset price is fixed at $100, still with 30 days until expiry, and instead of looking at a single $100 call option, we are looking at all call options with strike prices between $50 and $150. Let's take a look at the $90 strike call option here as an example. This is what the delta would be for each IV level. At 20%, it's 0.97. At 40%, it's 0.84, and at 60%, it's 0.76. The only thing that is different here is the implied volatility. The strike price, underlying price, and time to expiry are all the same. This difference in implied volatility between 20 and 60% leads to deltas ranging from 0.76 to 0.97. Bringing this back to what delta actually is, i.e. how much the option is expected to increase in value for a $1 increase in underlying price, this difference means that with 20% IV, this $90 call option would increase in value by 97 cents if the underlying price increased from $100 to $101. However, with 60% IV, this same option would only increase in value by 76 cents for the same underlying price increase from $100 to $101. More generally, you can see from the chart that the higher the implied volatility, the lower the in-the-money deltas are, and the higher the out-of-the-money deltas are. The higher implied volatility, of course, implies that larger price movements are possible in either direction. Or put another way, the less likely price is predicted to stay close to where it is now. This has the effect of decreasing deltas for in-the-money options due to the higher implied chance they could become out of the money. This also has the effect of increasing deltas for out-of-the-money options due to the implied higher chance they could become in the money. Remember, at expiry, it is only in-the-money options that will have any value, and it's the implied probability of being in the money at expiry that is affecting the deltas here. For in-the-money options, a higher IV increases the implied probability that it will no longer be in the money at expiry, thus lowering the delta, compared to if IV were lower. For out-of-the-money options, a higher implied volatility increases the implied probability that it may become in the money at expiry, thus increasing the delta compared to if IV were lower. In summary, the market's view on future volatility, as expressed via the option prices, and therefore the implied volatility, will have an effect on option deltas. Higher implied volatility will result in smaller deltas for in-the-money options, and larger deltas for out-of-the-money options. Lower implied volatility will result in larger deltas for in-the-money options and smaller deltas for out-of-the-money options.